Peripherals then, quite a short unit, not a lot to it. The first thing is that it's all about interfaces really, and we need to know a definition of what interfaces are. And they are basically the go-between between peripherals and the processor to compensate for the differences in their characteristics. If you think the processor deals with ones and zeros, and output devices, input devices and so on, they all work in analog, they work at different voltages, and when you send data there needs to be ways to check. So it's basically an interface is the hardware and software that allow communication between the processor and peripheral devices, much the same way as an interpreter would allow people that speak different languages to communicate with one another. So you need to know 5 functions of the interface, and these are listed here. So the way I remember at least what they start with is thinking puppy dogs bite very hard. So you get protocol conversion, data format conversion, buffering, voltage conversion, and handling of status signals. You need to be able to describe exactly what each of those do. Buffering, and these aren't obviously in the same order as they were there, is temporary storage of data, and it's a hardware solution. You need to remember that because we're going to compare it to spooling in a minute. Buffers are built into peripheral devices, so when you buy printers, especially if you're going to have a home network or a network in an office, you wanted to have quite a bit of memory in the buffer, because when several people try to print at the one time, it can kind of clog up your peripheral device. So if you've got a larger buffer, it means you can store more data temporarily. As well as that, it frees the processor up, because what it does is it sends the data to the buffer, and the buffer can work at the pace of the peripheral. So it means that once the processor sent all the data to the peripheral, the processor can go on with doing other tasks, and the buffer compensates for the differences in speed between the processor and the peripheral device, because the buffer then bleeds it out nice and slowly to the printer. The next one is data format conversion. So again, peripheral devices will work in different data formats and so on. If you think about the mouse, if you move the mouse, you're going to move it in an analog signal, and so the processor can understand that it has to be converted into a digital format. So 1 or 2 formats really is analog to digital conversion and digital to analog conversion, so that the instructions that are being given by the mouse or recording input from a microphone converted into the correct format so it can be understood by the processor. Voltage conversion, quite straightforward. If you even just pick up your keyboard and your mouse, you can actually see the voltages that they operate at, and they're quite high compared to the voltages that the motherboard will work at. And what voltage conversion does is converts it down to the lower voltage or the upper voltage, whatever is required of the peripheral device or the component to work at, to stop the components being fried in the motherboard, essentially. Protocol conversion, there's 2 protocols that you need to know about, and these just make sure that they're both sending data in the correct protocol, the correct format that needs to be sent in. And there's 2 you need to know about: odd and even parity. And it's a wee bit like the check digit. So with odd parity, the total number of ones in a message has to be an odd number. For even parity, the number of ones has to be an even number. So if one device was an odd parity and another device was an even parity, they couldn't communicate properly because they would keep saying that there was a mistake with the message they'd received. So the interface there converts it into the required format so that there's not that problem of them each saying there's another mistake. Handling of status signals. Status signals are just purely information about the current state that a peripheral device is in. So if you look at a printer, there'll be several different states that it'll be in. It might be sleep mode, off, it might be out of ink, paper jam. If you look at the flashing lights on the power button on a laptop, if it's solidly on, it means the power's turned on. If it's flashing, this could mean messages that might be in sleep mode. Basically to draw attention to the user of attention being required, really. And there's some examples of status signals on printers. So busy, ready to receive data, offline, paper jam, data not received properly, all the different sort of error messages are actual status signals that the device could be in. Buffers then, advantages. Buffers free up processor time by providing this temporary storage, and they're built in, like we said, it's hardware, sort of a fixed size. And hopefully this diagram kind of showing you that the processor can send data really quickly, and the peripheral device can't receive it as quick. So what the processor can do is send all its data as fast as it can to a buffer, and the buffer worries about then sending that data to the peripheral device to be printed. That's why they would say it's a temporary storage, and that frees up the processor to go on with other jobs after it's sent the data out. Spooler is another method of temporary data storage, and what that is a software solution to the problem, and it uses fast back-end storage already on your computer system in order to temporarily store data. And again, it's the same idea as a buffer, except it uses the back-end storage built into the computer system rather than the peripheral device, and that's where the difference is. It's probably more advantageous to use the spooler because you can have a lot more memory as a temporary storage if you use all the back-end storage in your computer system as opposed to on the peripheral device like a printer. So there's just a kind of summary of what we just said there. Spooler makes use of idle periods when you're not using your computer system to get data to get the data sent to the peripheral device. Buffer has a fixed size, spooler's usually larger, and in practice they really use both of them when you're printing, especially in networks and so on, because there'll be so many people trying to print at the one time. And again, this is just a wee area you could do a wee bit more reading into, in fact, just to make sure your knowledge is up to par with what it needs to be. The next bit of this is solid state storage devices, SSSDs. So a solid state storage device is a device that contains no moving parts. So things like that are in your iPod, no moving parts, the solid state memory, newer laptops, flash cards in your phones, USB keys are all using flash ROM so that there is no moving parts. And because there's no moving parts, it means that they can be smaller, so we're starting to get them even smaller than the ones in your phone that are storing 32 gigabytes. So we get them in cameras as well. And the advantages of them all is that they're very small. There's no moving parts, which makes them more robust. Because there's no moving parts, they use a lot less power. So your devices that use them will be able to stay turned on for ages. And other advantages of them, you can get security applications where they're startup keys for really important devices, where you would require like a couple of USB keys to put into computer systems in order for them actually to work. So you need to know the kind of advantages of them, and that is that there's no moving parts, they're more robust, they're getting physically smaller, data transfer speeds are getting higher, the price is reducing whilst the memory you can fit on them is becoming increased, the capacity is increasing. Developments in back-end storage then, just kind of saying there actually, the capacity of the devices that are coming out now is increasing. So DVDs are getting nearly 5 gigabytes, Blu-ray DVDs 25 gigabytes, and there's more and more technologies coming out all the time. And think about broadband speeds in your area. Virgin are doubling them at the minute, and these are much vastly increased from what dial-up used to be even 5 years ago. The speeds are crazy that you can start to get now, and there's more research going into technologies like holographic storage, where they're using different light and different angles to record data in things the size of postage stamps, but you can store up to 2 gigabytes in it. So these are sort of the area, if you're interested, you can go and do some reading on to see what's actually out there and coming up. Other developments in back-end storage, the read-write speeds are also increasing. USB 3 is out now, and it's much faster than even USB 2. FireWire's increasing, so the data transfer speeds, the actual time it takes to write large files to these devices, is becoming shorter all the time. They're becoming cheaper, so per bit the storage is much cheaper. One of the implications though is that as these new USB 3 comes out, if you look at iPhone just now, the new iPhone's not compatible with the older iPhone connections, which is a bit of a pain for a lot of people. Physically, they're getting much smaller, which means if they're built into devices like cameras, mobile phones, laptops, these actual devices can be much smaller. And the current trends with interface speeds is that the data transfer speeds are increasing. I think we already said that one, in fact. Wireless transmission you need to know a wee bit about, and there's two different sort of types of wireless transmission you need to know about. Wi-Fi, which stands for Wireless Fidelity Alliance. It's over a kind of short area, so this is what you tend to get in like your McDonald's and other shops, as they use Wi-Fi, and as well as at home using Wi-Fi and wireless. Whereas in your devices, like your phones, and they're not really using it so much anymore, but still get a lot of Bluetooth devices, so like wireless keyboards and mice use Wi-Fi. Infrared's the other type of wireless as well that we've probably spoken about as well. Another important thing, and they usually ask you to draw a diagram, is serial and parallel data transmission. So serial data transmission, it sends one piece of data along a single wire, one piece of data at a time, and it's much better over longer distances. Okay, so the diagram you need to draw for this one's really important as well. So it has more than one wire. It's got another wire to just check that data has been received correctly, but when you draw the diagram you can just draw two boxes with a line connecting them and a bit on them, and it sends one bit at a time along the data line. One bit on one wire is really what they all do, compared to parallel data transmission, where there are several wires and several bits of data are transferred at the same time. So you can see the difference there is that there's a larger amount of memory being sent at the same time. So similarly, this one, parallel data transmission, is generally used over shorter distances as it's much faster, less chance of errors in the message corrupting, and it sends multiple bits of data over multiple wires simultaneously. Very important that you get those descriptions good. As part of this unit, you're supposed to do a little bit of research, which we've already done in class, and you need to know about hardware and peripheral devices, so hardware and software, to do these different tasks. So what hardware and software for creating a multimedia catalogue, the same for creating a LAN in school, and the same for developing a school website. So you should have a read over them, but some of the hardware to create a multimedia catalogue would be things like keyboards, digital cameras, scanners, high definition screen, printers, projectors, video cards, sound cards, things like that. Creating a LAN in school, we're going to need network interface cards, servers, hubs, and routers, switches as well, you could say. And developing a school website, digital cameras, scanners, keyboards, mice, all the kind of basic essentials plus some others. Now that's a wee bit you should go in and do some reading into as well, and a wee bit of research, because that tends to pop up in the exam as well.